Here we have a problem where we are asked to solve for the resistance of the heater and prove that its value is around 44.1 ohms. Now we are given a rating of the power heater, which is 1200 watts and at 230 volts. What would be the resistance, or how we would prove that the resistance is 44.1? I'll be using a power dissipation approach, which is V squared over R. Okay, make your R the subject of your equation. That's R equals to V squared over P. Then substitute all your values. You'll get 230 squared all over 1200. That ultimately gives you 44.1 ohm. This proves the resistance given by the problem. Next is that we want to find out what's the total resistance of the cable. We'll be using this equation R is equals to resistivity multiplied by length over the area. We all know that the resistivity is around 1.7. 1.7 times 10 to the negative 8 multiplied by the length. It's the length of the wire. 9.2. Okay. All over. What's the diameter? So the diameter is 0.9. So that gives you pi times 0.9 times 10 to the negative 3 squared all over 4. Okay? That gives you a value of 0.492 ohms. This proves this value. Now the last one is that this one, the current in the cable and the heater is switched on. Determine to three significant figures the power dissipated in the heater. All right, so in order for us to use power dissipation, that's equals to I squared times R. But we don't know what's the current yet. So we need to solve for the current. That's current equals to voltage over resistance. We know that resistance is 44.1, so that's 230 over 44.1. 230 divided by 44.1. That gives you 5.21 amps. Then use that to solve for the value. 5.21 squared multiplied by 44.1. Okay. 5.21 squared times 44.1, you get 1197 1190 watts. This is your final answer.